Hi folks! Hello, Pavel here from Working Devices. And yeah, I thought I would make a short stream today a little bit earlier than usual and go back to what we were doing yesterday, which is trying to build an expander prototype. So yeah, yesterday we got the um, case link port working, the LVDS transceiver. We got hooked up to the GEL board with a SAMD21 microcontroller, and we did manage to receive data from the Keras module, which has its own LVDS transceiver over there and the connector built in. So today I'd like to see if we can make the microboard actually do something, and then we would need to start tweaking the Keras code to allow for more channels, basically, which is probably going to be the most challenging part. But we'll see how that goes. Yeah, today I think we're just gonna try to hook some I/O into the into here. Yeah, maybe actually we could even just replicate the main channels from the Keras to here, just to try it out. So I get some op amps here. I've got a bunch of buttons, long buttons, short buttons. Yeah. So the general idea for the expander sorry, is to have either 4 or 8 channels on a 3U module, perhaps a 1U module as well. Right, and have those operate in the same way that the channels on the Keras work. So let's see if that should be working already. So we have the 4 channel buttons here. Oh, yeah, I guess it stopped. Let's see. WhatsApp. Is the program running? No, it's not. Okay, let's restart the debugger. Now we're working. Right. And I feel like this panel has stack buttons. Oh no, they work just fine. Okay, so those are the 4 channel buttons, right? And typically you switch between the channels just by pressing the channel button, obviously. And there's a couple of combos that also take the channel button as like an argument, let's see. So for example, to switch channel modes, I hold gate and press a channel. Right, so for example, I can set this to a combo channel by holding gate and pressing channel 1 twice, right? And see now the 2 LEDs for channel 1 and channel 2 are both lit up. That means we are in a combo channel, right? So basically I want the expander to work the same way, right? So we will have the let's say experience, right, or the workflow transfer from whatever you do on the module itself to the external channels, right? So it would also have a button to choose a channel, right? And then you'd have that channel's output on the expander, right? So you could perform all the same operations you would do here with an expander. Yeah, that should be pretty obvious, right? So I'm gonna want to have the buttons connected to the board, and we're gonna try to make some outputs. So we could start with just gate outputs. We could try to use the DAC that is on this MD21, or we could also try using the PWM output. See if we can get like any kind of sensible results that way. Honestly, I haven't looked into the parameters of the PWM that this can do. At least not recently, so you would need to see if that is feasible or not. Yeah, anyway, so I have some op-amps here so that we could set those up to do, you know, our Eurorack level outputs, right? Because this is a 3.3 volt system. Also, we have the machine at Bristronica this week. I mean, this weekend specifically. We are leaving on Friday. Yeah, we're gonna be showing up. So you can come to our booth, come talk to me and Łukasz, and try the module, obviously. I think we figured out already how to pack. So yeah, that was a little bit of, you know, last minute thing, but yeah, we figured out we can just put the modular in a gym bag, and you know, we should be within the luggage limits. So yeah, unfortunately we'll be able to hold the entire 1U case. I mean my palette. We thought about taking Łukasz's, you know, the 7U Belfaco case, but you know, that would be more of an issue to fly with. Yeah, the palette is just fine. So anyway, I don't know if you can, if there's a reasonable chance that we can, you know, make this expander in time. I mean, even if I could, like, this is, you know, a mess of wires, which is like definitely gonna fall apart once I, you know, try to make a demo with it. So that's more just for fun right now. And like, we seriously want to, like, we want to start working on this. We have to start working on the expanders more seriously once we launch the module. And of course, for that to happen, we need to reach our Indiegogo goal, which is currently like around 22 modules away. So if you like what we're doing, please support us and pre-order your covers. So you can get it on Indiegogo here at a slightly lower price, or actually significantly lower price that we want the MSRP to be. I mean, there is possibility that the final price will change. This is not yet like set in stone or whatever. I mean, that kind of depends on how the costs will look like, but pretty sure it's gonna be more than what we are offering at now. So, you know, if you want to, first of all, help us make this happen and perhaps get it significantly cheaper, you know, arcane.audio, yeah, pre-order yours here. So anyway, let's get back to work. Oh, did you actually see that? Because I keep forgetting to move my camera here. No, yeah, it's fine, right? You can see it. Okay. Yeah. Anyway, let's maybe start with putting the button somewhere. So there's a bunch of other crap on this breadboard. Like, ignore this. I was trying to make and this actually kind of worked. And a diode ring mixer for like a completely different project. And this is some kind of filter, switching filter thing. Okay, so again, let's see if I have more buttons here. Just some weird ones. Yeah, I'm out of those long boys. I need to resupply them eventually, because those are perfect for modules. Like if you put those at the same level as the Funky Kong jack, they stick out just the right amount. I'm afraid I won't have 4 buttons. But doesn't matter. 3 will do for now. Just for testing. Let's see. Are those like digital and analog pins on the board? Yeah, and I think they all can be analog, so it doesn't matter which ones we will use. Maybe we can make the camera bigger. Yeah, that works. So yeah, this is the receive from the caress. Right. So the trick is we need to make the caress both read and write to the expander. So we're gonna need to figure out some kind of a protocol to facilitate that. It shouldn't be too hard though. So I think what we can get done today is just, have this button actually activate a channel, like one of the built-in channels. Yeah, I'm not gonna attempt any kind of nice wire management here. This is very temporary. Let's say our ground is gonna be here. Let's see what power this split. here. This is gonna be our ground. Let's try not to break those stain wires, because that would be a huge pain in the butt. Of course, I already pulled one from here. All right. So we got our buttons. Okay, and we still need to connect the ground back to here. Yeah, good. So we can go over to our Arduino and do a bit of Arduino sketching. Are we good with the connection? Let's find out. So the serial monitor is not coming up. Did I unplug this? No. It should be good. Oh yeah, it's running now. Oh yeah, there we go. So this is still transmitting those zeros and A's. I think this USB plug is a bit wonky. Maybe let's give it a bit more space. Yeah, no, that works. So now maybe let's try and actually with the buttons. So I wanna set some digital inputs here and some pull-ups. Of course, I don't remember my Arduino functions, so let's get googling. Tutorial, okay, sure, fine. Pin mode pin mode, okay. So which pins are we using? 10, 9, and 8. Okay. Pin, no, what's that? Oh, input pull up, okay. 9 and 8. Let's do a digital read from each of those. So actually, let's maybe make a loop. from 8 to 10. And let's just print it out to the console for now. Sorry, my mic is in the way of the keyboard. Yeah, this tends to happen for some reason. With those Arduinos. I'm not sure what's up with that. But anyway, are you gonna let me upload or not? We might need to do the tap thing here again. By which I mean tap the reset. Oh no, it's on the other side, isn't it? There. No device. Oh, that bit. The plug just broke. Oh, the socket broke probably. No, it's lit up. Okay, I'm gonna upload. Please work. Right, successful. Verify successful. Awesome, there we go. So, what are we reading? 111. Okay, so can we send some zeros? Oh yeah, nice. Okay, so the buttons work. So the next thing I would like to do is actually read those over the serial. So I'll make the module read those over serial and see if we can make it activate a channel or simulate pressing a channel button there. Okay, so the way I'm thinking I'm gonna do it is we're gonna do a serial read and basically match that with or interpret it as a command. So I'm gonna do a switch on X. Okay, and let's say R will be our read. And let's say S will set the DAX. So I could do something smarter, for example, encode with CBOR, but I think we're gonna keep it simple for now. Also, the way I would like those to work in the final product is have those expanders daisy chainable. And for that, they will, need to retransmit basically the data that comes in, right? The uplink from the module down to to other expanders. So there would be two jacks, two connectors like that on an expander, and one would be up to the module. The other would be down to the next expander, right? And then there needs to be some logic that controls how the data is retransmitted. So I have some ideas already on how to do that, but that's that's for later. Now let's get something basic going. Okay, so anyway, R for read, S for set, and that would I would expect that this would be followed by a couple of numbers, so a couple of values to set. And then we also, I guess, want an LED command to set the LEDs here. Actually, I might not have enough I/O on here. Let's see, to put some LEDs here, unless we do an external DAC, then I guess that would work. Okay, so how many pins do we have left? So those are taken by the UART. Now I have 4 buttons. Yeah, so 4 pins, 4 function pins would be left, I guess. Or maybe 5. Oh wait, let's see. So we have 3 here, 4, 5, 6, 7, 8, 9. Yeah. So I guess we'll have 5 left. Although you could just plug in some kind of multiplexer or like a shift register in, and do I/O, like do LEDs and buttons, don't I? Actually, I think I already have an LED driver somewhere that I could just use. So yeah, something like that, I suppose. Anyway, let's not worry about the LEDs for now, since we are just replicating the built-in channels. Okay, where's my code here? Oh, there we go. Okay, so actually I'm gonna oh, never mind, it can be here, no worries. Okay, so when I get a read command, I'm gonna do this thing here. I hate this editor. Okay, so what we gonna do here is I'm gonna read the buttons, and we're gonna have an output. Actually, let's count from 0 for this. So basically, we will send a bitmap, right? Where each bit corresponds to a button. Right, and now we need to transmit this over serial 1. Does it write bytes? Yeah, it does. Okay. Something like this. Maybe we should actually prefix that with something, just so it's unambiguous. And we know that we are reading the right thing. Okay, so that kind of looks alright. So let's go back to our chorus code and change this up a bit. So we want to send out an R. And then we want to do a read. Let's make a buffer. How long do we want it? Okay, so 2 will be enough for now. And we want to receive 2 bytes. I'm not doing any, kind of error recovery yet, so it can hang and it can break. So that's gonna be our read count. Again, I'm typing with the mic in front of my keyboard, so that's a bit awkward. But anyway, we want this to have an R back. And if that is true, that's gonna be our button state. So maybe I'm gonna have a separate function here. Let's say process X buttons, something like that. Let's call that a register. And that's gonna take the second byte that we receive. And let's just print this out to the debug console for now. So how do we want to do it? Let's just print a hex. What's up? And then now this suddenly took so long to build. I guess maybe my height. Oh yeah, the mic is getting a bit hot. Anyway, load that, and let's see if we've got anything. Okay, it's not reading anything yet. Oh wait, we didn't upload that sketch yet. Oh crap. Sure. So we're gonna get a read here. I might actually need to restart that since, again, we're not doing any error recovery. It might be scope time. Wrong serial. Don't press Command S. Actually, we should save that. Oh. Check that out. I am reading some buttons. Hell yeah. Hell yeah. Maybe let's make this output a little bit prettier. So, just if you didn't realize what's happening here, this is what the module sees, right? So we've got the module talking to our quote-unquote expander, and that thingy reads the buttons and gives us back this output. I mean, the output is from the cars, but it reads the state. Let's make a prettier print here, just so we see what's going on. There we go. Kind of. Oh yeah. Yeah, obviously this was not supposed to go here. Anyway, buttons 0, 0, 0, 0, 0, 0, 0. And if I had more buttons, it would be another 0, but I only have those angled ones. So, well, I mean, I can put an angled one in there too, why not? Actually, you know what? It doesn't matter. So now how do we communicate this to the main thread? So the thing is, this is running on a separate thread, and you know, we need the main one to you know, synchronize the access to the button states. So the way I typically do this is I use those free RTOS mutexes, which work pretty nice for this. Actually, you know, maybe it's time to add a new module to our project. Oh, module, I mean a new C file. A module is a bit, you know, rich for C. Let's call this external. Right, and let's add a header. Let's go there, external.h. Sure. Where do I put this? And we're gonna need to edit the project here so that the makefile builds this this object there. Existing items. And we probably don't need to attach the header files. Generate the makefile. Oh, that's interesting. I forget that that is there. External. External. All right. We need the user header. And we need the RTLS headers. Right. Now let's get to the synchronization issue. So for that, I guess we're just gonna do some copy pasting. So the general structure I think we are gonna follow here is like this. So there is a task function, which we already have here. Then there is basically set input or update input function, which gets called in the main thread, and that takes this platform IO thing as an argument and updates it with data from this quote unquote module. And that platform IO thingy, that's basically a part of the core. The core Rust code. So yeah, there it is, right? So the platform IO basically has all this system level state. So panel buttons, LEDs, DACs, right? That all gets populated, both by the system level code to notify the Rust core and by the Rust, up logic, then to update the outputs. So we could actually put the external buttons here. Yeah, so I think like the way I had this for the panel is like this also tracks if the button has been pressed and released. Yeah, exactly. So yeah, we could do the same thing, just copy this logic over. I guess that would be easiest to do, because then that gets translated into a method call on our controller, so that has a button pressed and button released methods here, right? Get called if this is set. So yeah, so that's the structure, right? The main thingy and the update. But there is also like one important piece to this, which is we basically need to lock access to whatever we are sharing between the threads. Okay, actually here this just does a semaphore, which gets raised when. But yeah, this also does the synchronization just one a little bit differently. So actually maybe the one I want to look at now is the LED driver code. Yeah, so this has an LED data mutex. I'm just gonna copy that over. Also, I think we need to include the FreeRTOS thing, yeah, semaphore. And also we need an init function, just so we have a place to init those semaphores. Should I say void here? It's kind of old school, but yeah. Like if you like wondering why folks put this void here in the C argument list, that's kind of also like a historical, artifact, in the sense that like you used to be able to do, or like in early C versions, which I think it was like even before the original ASCII, if you did that, that meant that the actor is like the argument list isn't specified, basically, right? And then you would have them. Well, that's like a whole story, but there was like basically a different way to deal with arguments in the earliest C, and then they put these voids like to differentiate between no arguments and unspecified arguments. Anyway, let's make a mutex now. Like this. But we're gonna name it something else. So that's gonna be semaphore handle ext data and semaphore buffer ext data. Did that update the names here? Yeah, it did. Oh, but we also updated here. Nope, that's not what I want. Let's undo that, it's break too much, because again, the VI plugin for VS Code is a bit wonky sometimes. It tends to undo too much. Okay, yeah, now we lost the initializer completely. Okay, I guess we are gonna do it the hard way. Then actually, why don't I make this static? Okay, so we get our semaphore. I mean our... wait. No, I want a mutex, not... I want a mutex, not a semaphore. Oh no, oh no, that is a mutex. Okay. Sorry, the name here tripped me up. So it's semaphore create mutex or semaphore create binary semaphore. Right. Right. Okay, so here we are gonna look. And obviously we will need to make this serial IO non-blocking, right? Because otherwise that's gonna block our main processing thread. Or is it? No, actually not necessarily. You just need to make it like lower priority. Yeah, actually, what is the priority there? Okay, same as start, so that's good. That's where I want it for now. So again, here we are gonna lock. And yeah, if we can't lock, just continue. Yeah, perhaps make the delay here. Again, this is a very rough and ugly way to do it. Eventually we're just gonna make the serial access non-blocking, and then this task will just yield when it's doing IO. Oh, come on. Oh yeah, and also this will need to, like in the quote good version, this will need to wait for the main loop, so to start doing something. So instead of this delay, we basically want to wait for the main process to finish and then initiate a read of the IOs, right? And only then we would enter this the space here. So the same way we do it here, right? So this waits for, so this is actually for output, but the idea is the same. So we wait for a semaphore to signal that the main thread produced output, and when it did, we move on to actually exchange data with the LED driver, and also then we log the access to the data with this other semaphore. Actually, this happens somewhere else, but anyway, yeah. So there's an LED data mutex, and they have LED update semaphore, which signals that the update is ready to process. And so for now, I'm not gonna do that here. I'm just gonna run this in a loop with some delay. Yeah, so we want the next thing we want is a function to copy that state, the state of the buttons to our platform IO. I want this to be volatile too. Just to be sure. So we want to be volatile basically if you do stuff like in an interrupt handler, right? Just to tell the compiler that the value is in memory and not in a register. Yeah, let's get rid of that for now. Lock next data, whatever. So that's gonna just store the button state to here, right? And then we want to and then we want to be able to store that into the platform IO. Just give me a sec here. I screwed up my OBS preview there. Actually, let me make it a bit bigger for you. And that's gonna say ext set input update. Now I need the platform IO definition. Which is here. Now why are you screaming at me? stdlib. It's not, yeah, it is there. Don't worry about it. Okay, so I guess I'm just gonna copy over this button down logic here. Even though I don't need like the whole button count, 17 buttons. Also, like, let's make those static so that the names don't clash. Hmm? Right, and we are gonna determine if the button is down by our ext buttons variable bitmap. That's gonna be end1. Alright, that should work, I think. Let's put those together. Clean up a little bit. Right, and oh yeah, and also we need to lock here. So yeah, we're gonna attempt the lock, but just wait for just one iteration. So if we fail to lock, we're not gonna do anything. Just return. So that we don't lock the main thread unnecessarily. Okay, let's see if this builds. Oh yeah, and also the button level that needs to be flipped, because it's 1 for not pressed and 0 for pressed. Let's see. Yeah, let's just do it here, I guess. Why are you screaming at me again? Yeah, okay, it's fine. Oh no, actually it's not fine. Yeah, that would... Oh, is it? Yeah, it is, right? Anyway. Whatever. The MacBook is getting slow, sorry. Stream is hugging it. Oh yeah, we need to import, we need to include stdio. Sorry. And also, we actually need to call the update thing. So maybe we can do it here. Next, set input update there. All right. So, does this do anything? Now it crashed actually. Did we crash? What's happening? Yeah, we did. But where? Crashed on the semaphore. Oh yeah, because we didn't init the semaphore, of course. Of course, we need an init. Here. So next init, that should do. Oh, init external. External. Yeah, my naming isn't very. My naming isn't very consistent. Okay, that looks better. Let's see. Button. Doesn't do anything. Oh wait! Whoa! God damn it, it works. It freaking works. Let's try gate plus channel. There, yeah, damn, it works. Freaking A, man. I mean, it doesn't work perfectly, but so I'm pressing the expander button. Okay, and now it broke. I think I may have disconnected the USB. Okay, yeah. All those wires here. Yeah, I mean, it's fragile as heck, but let's see, like, let's do it no hands so that, you know, you believe that this actually works. Can you please stay in place for a second? Whoa! You see it? It hacking works. Awesome. Awesome, man. So now we also want to send the dark levels over. That should be easy, I think, actually. Let's see. So I'm gonna put you in. Wait, do I want you at 16? Yeah, we do. Next tax, and let's have 4 of them. I need those to 0. And now the input update will have another loop here. And let's not be extra with the names this time. Oh shit, those are not on the IO. Those are separate for historical reasons. And that's fine. That's fine. We can pass those. Yeah, so the dark levels get passed here. That's fine. We'll just take another argument. Now are those Uint64s? I mean 16. Yep, they are. Perfect. So now, in addition to writing this, I'm also gonna write the tag levels, which were, if we recall, S? Wait, I don't know why I call this S. Maybe for set. That's fine. S is fine. So we're gonna want to send 3 bytes, and that's gonna be S. Then it's gonna be, no, actually, we want to send 4 dark levels. What that means is that we're gonna need a buffer. So let's make actually a second one, because I don't want to mess stuff up by reusing the same buffer. Oh, actually, no, that's fine. We can reuse the buffer. So how many bytes do we need? We have the S at the beginning, that's 1. And then we have 4 16-bit values, so that's gonna be 8 bytes. So 9 in total. Okay. 9 bytes it is. F0 is gonna be the S. And then we're gonna go through the dark values. So buff 1 plus 2 times I is gonna be ext dax I. That's gonna be the high byte, and then the I plus 1, so let's say 2 plus 2 times I is gonna be the low 8 bits. Alright. And then we just gonna send our buffer over. But first I need to fix this. So we wanna now read those bytes back here. Float version of pass int? What? 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 Anyway, you know what? Let's make a block here. What if I did this? So like the Cortex M is gonna be little endian, right? No, that would flip the bytes, right? If I just read into every variable right there, like that. Would it? I mean, I can just send them flipped too, so. Whatever. You know, let's just keep it safe. Okay, so let's start with some analog outputs. Okay, let's see what pins do we have left over. Those 4 here would be nice. So that's A9. Oh, that's A5 in Arduino. Okay. So 5 is gonna be output. And so is 4 and 3 and 2. And I'm gonna need to look for some LEDs. Also, yes, I know this could be a loop. Right, was it right analog? Or analog right? Yep. Oh, there's a resolution. Okay. Okay. Can we do... Oh yeah, that's the PWM thing, right? We need to look into that in a few seconds. So it's 32-bit uint. So is that supposed to be left aligned? So pin is gonna be 2 plus I plus I, and the value is gonna be DAC, but now we need to figure out if we should shift it over to the left. Let's consult the docs. Okay, it's 255 is always on. So is it 8-bit or is it 32-bit? Okay, so it defaults to 8 bits. Ah, I see. I see. Okay, so in that case, let's start with 8 bits and then we are gonna... Oh, it's 16. And then we are gonna perhaps increase the resolution. Now let's see if I can find some LEDs to plug here, just to see if this works actually. Actually, you know what? I'm gonna take a break for a second. Gonna be back in like a minute. And we're back. So, I'm gonna take 1K resistor from my fresh bag of resistors. There's some space in here. How about use this space for our LEDs? Because I won't have easy access to the 3.3 volt rail here. Because we're gonna make them we're gonna drive the LED from the 3.3 rail, and we're gonna do the PWM on the low side. Okay, so and a couple of those white ones which are pretty nice and bright. Fortunately, I don't know they still work, so again I need to see. Okay. Wire. Okay, so first let's try jumping this to ground just to see if it works at all. Yep, we have a LED. Okay, so which parts were we using? 2, 3, 4, 5. Okay, so this is gonna go to 2. This one is gonna go to 3. Heck. I broke it. Are we still in the right orientation? Yes. Let's have another 1K. And the buggy. Awesome. So let's load our program in now. What? What? Oh yeah, that was supposed to be 2 bytes long. Right. I mean towards, yeah, 2 bytes long. Yeah, pretty much. Okay. That is in. Now the host or module program. Oh yeah. So the buttons still work? They do. Let's see now about those. Okay, so we don't have the LED lighting up yet. Is anything happening here at all? This was maybe ground. Okay, so we are getting some pulses here. That looks weird though. What is this? That does not look like PWM at all. Some random stuff. Okay, let's try printing what we are actually receiving here. Print F. Perhaps we are reading this or passing this wrong. No, it's all zeros. Okay, sure. Yeah, that looks correct. So what is that crap that's we're getting on the output? Actually, you know what? Maybe we can put the new line. Like maybe we can put them on the same line just to have less noise in the terminal or in the serial monitor, I guess. Yeah. Yeah, this looks correct. Oh, also, apparently we did override the buttons on the panel. Sure. And this doesn't work anymore. Wait, what? What's happening here? Something is screwed up. This should not be happening. So let's fix the button first. Can we? Yeah, I guess we can. So just gonna do this junction here. Now no idea why those don't work anymore. Maybe I'll just busy with this thing. Okay, so the buttons work again. And we got some deck action. But still some noise on the PWM. Okay, perhaps we need to switch pin to analog explicitly. Oh, I don't need to call pin mode. Okay. But they do here, so let's zap. What is this crap here? Like, I don't know, maybe are we writing too fast? that be it? I don't know what's up with that. And right. Oh, 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 oh. What the hell was that? And now this is doing something weird again. Okay, maybe I want to restart. Looks like we're hitting some kind of exception when dealing with the input data. Whoa! Raw. Okay, I don't know why channel switching doesn't work anymore. But we did light up the LED, so nice. Now, what's up with that one? Is this flipped? Perhaps. Oh, oh. I see. Hmm. It is possible that this LED is just cooked. We have 3.3 here. No. Why not? Why no volts? Why no volts? Bro. Okay, I see. I get it. I get it. Now we get volts, don't we? Yep. Do we have volts? Yes, we do. Let me try a different LED. And there we go. Okay, now this is flipped, of course, because we are switching low side. So this needs to be 255 minus this. Okay. How about the buttons? Are they still broken? Yes, they are. Yes, they are. And this is kind of broken too. Not sure what's happening there. Are we overflowing some buffer or something? Hmm. Now it works. Oh, okay, something gets stuck here. Okay, so get some kind of sticky buttons issue. I think I want to set X buttons to X buttons to high by default. Right, because we flip them. Because we flip them here. Mm-hmm. Okay, nothing. Okay, now they work. Oh, we get a panel reader. I don't know what that thing at the beginning was, but yeah, now looks like both the panel and the external buttons work, which is awesome. Which is goddamn awesome. Yeah, so we've got the DAC and we've got we've got the DAC on the expander and we've got the channel buttons on the expander. So pretty cool so far. Yeah, so I think that's gonna be the end of the stream for today. And next time we can maybe put an op-amp in front of this, so we can take this to your rack levels, add a filter for the PWM, and yeah, maybe increase the resolution. Right, and that would be pretty good already. Yeah, we might put like indicator LEDs here too. But then we'll need to figure out how to manage the output pins. Like, should we get a bigger board, or should we add a multiplexer or shift register? Like, all these options are fine. Right? And if that works out, we can actually put it on a little PCB. Alright, so hope this was at least a bit fun. Again, come over to arcane.audio and remember to support our Indiegogo campaign, which also you can find at arcane.audio. And this is what all this is about, right? The Cars of Stars sequencer, the thing that we are I think right now right here. So as you can see, the expander is in the rocks. You can make a serious expander out of this a little bit later. But first we need to launch the actual product. I mean the main product. So see you in the next one, and if you are coming to Bristol, come say hi at Machine Bristronica. We'll be showing the carousel off.